This is another episode about the ETH conference, which I think was really good. Kudos to ETH for doing this. This time it's Sergey Levine. He gave a talk about robotic foundation models and reinforcement learning. And I think, not surprisingly, he is very much in line with the strategy that we have at Orange Capital Partners, and that's because we actually borrow a lot from him. So it's not like he's copying us; that we're in line with him. It's not like we're copying anything. I mean, he's a researcher, an entrepreneur. We're investors, so there's nothing to copy here. But we have a certain, let's say, credo, the way we believe in the robotic learning pipeline, and I think his talk here reflects that. He's talking about pre-training for a general understanding of tasks without special skills. So he's using the large language model recipe of pre-training on a large data set. That large data set, I think at this point, has to be video presentations of humanoids, of humans, and therefore the humanoid robot is the main sort of translation due to the relatively small morphology gap. There is a possibility for world models to come in, and I think the pre-training can happen actually from very different sources. It can be actually even imitation learning, behavioral cloning, even robots themselves, and video. But what you need in general is a large data set of presentations that teach the model fundamental spatial know-how. So I'm here. If I want to open the door, I have to walk towards the door. I can't stand in the way of the door. And I open the door. I mean, all the kinds of stuff that we obviously take for granted because we have that ability, almost from birth. The key of his presentation is the mid-training part, and that's for example, Aviral Kumar spoke about this also. He's a PhD out of Sergey's lab. I think this crowd, let's say these people around physical intelligence, around Sergey, Aviral, and the people in robotics that follow this trajectory, they have subscribed to the recipe, and they have taken the mid-training part very seriously. And I think that's where we resonate very much, because once you have a general understanding of spatial intelligence, of what it means to screw a screw, like, okay, there's a screwdriver, there's a hammer, there's, you want to clean an apartment, you want to fix a tire, like all of these things, there is a lot of intelligence in just looking at these things. The same way if you watch people surf or watch people dance, you will get a sense for what surfing and dancing means. You can't dance, you can't surf, but you know that surfing is not skiing. You know that dancing is not playing soccer, etc. So you have a certain understanding. Now, the mid-training part in Sergey's presentation covers okay, how do we teach the robot skills? And here Sergey recommends a reinforcement learning algorithm that is trained on policy in the real world with a robot. So the robot has a certain understanding now of space, of tasks, but it doesn't know how to nail a hammer, hammer a nail, or screw a screwdriver, or open a bottle, or clean a refrigerator. And now we're using automated reinforcement learning. So that is an RL algorithm that is very sample efficient. So because it's in the real world, we don't have hours to train, and we also cannot, in principle at least, not waste a lot of resources here. So we want the robot to quickly learn how to do these things. The reinforcement learning algorithm works according to the actor-critic model. So there is a certain there's the actor, which is the model, and then there's the critic, which is the reward, and then that goes back and forth, and you either get a better reward or not, and you kind of morph towards a solution to the problem. So that's his suggestion. And very importantly, he also suggests another very important thing in our opinion, and that is the robot in the loop. So what he wants now is he wants to train the generalist, so the model that has been trained on general stuff, and he wants to bring that specialized data now into the model. So therefore, the generalist now also has the skill of hammering a nail, screwing a screwdriver. So that's his recipe. I think, we've spoken about our sort of robot learning pipeline, or the way we see the robot learning pipeline, and we see it very similarly. In fact, this mid-training part that he covers with RL, he says there's optionality also maybe to have imitation learning, to have behavioral cloning. Like there are different other options to do the mid-training. But it's important for scalability and cost issues to have an automated way. And we fully agree with that. And what's also very important is to feed the data back, to use the robots. And we spoke about this yesterday when we spoke about, when we commented on Lalden Koltun's presentation. The robot in the loop means that the robot also becomes a data collection engine, because the robot is the only actual device that has actuator data and state data at the same time. So this is akin to Tesla's FSD, when they trained the FSD with the video and the driving and the shadow mode. They had, or even when they trained it on without shadow mode. But the point is, they had meaning when they use behavioral cloning. So they had the data of the actuator, the gas and the brake and things like that, and the steering wheel, and the situation, the state. That's important. That's why we need real world data, because we need that. The same way, if you want to serve a 10-foot wave, there's no other way for you to do that than to actually do it. You're definitely not going to be good at it if you don't actually do it. Now, I think, if I may indulge, a next step from this, in our opinion, would be that the robot generates its own trajectories. This is something we spoke about recently with the Harvard professor, Du, I think Professor Du is his name, where you generate your own trajectories. So the exploration phase is such that you generate your own trajectories, and then you have an actor critic maybe classify the trajectories before you even try. So therefore, the exploration phase could be improved, could be accelerated and made more efficient. Also, Aviral Kumar's idea and that's something that also Sergey shares, which is the idea of having sort of, instead of correcting the robot while it's executing the task in mid-training, you just give it a sort of a hint. You correct its data, meaning you don't show the robot how to do it. You only correct the robot when it's off track, so it can then keep exploring and finding its own solution, which is, of course, the old saying, if you teach a fisherman how to fish and things like that. I mean, that's kind of the same idea. Don't show the robot how to hammer a nail. Just let it figure it out itself and help it when it gets off trajectory. So to summarize, I think Sergey's presentation, it's nothing dramatically new for us, but I think, again, every time he speaks, I think it's worth commenting on it, because he, in my opinion, is the cutting edge of robotic learning. He has a robot recipe, which is pre-training at scale data and then mid-training through automated reinforcement learning, and also including imitation learning and any other kinds of behavioral cloning, teleoperation. All of these things can be used to improve the pipeline, and then feed it back. Very importantly, feed it back, and then maybe down the road we have video generation on policy in real time to help with exploration. So we have sort of a pre-selection of trajectories before the robot even tries in the real world. Thank you.